Hello viewers and welcome to this series on laboratory testing in highway engineering. As we know, aggregates are the prime constituents of different layers of road pavement. The aggregates are subject to bear the impact load caused by moving vehicles. The property to resist the impact load is termed as toughness. It is determined by aggregate impact value. In this program, we shall see as how we determine aggregate impact value. As per IS 2386 part 4, the apparatus required to determine impact value consists of an impact testing machine and other equipment shown here. First, let us see the impact testing machine. So, here we see the impact testing machine. It has a heavy base weighing between 22 to 30 kgs. There are two clamps provided at the base to hold the cylindrical cup in position. It has two vertical guides which control the movement of a hammer weighing between 13.5 to 14 kgs. The bottom part of the hammer is cylindrical in shape with a diameter of 100 millimeter and depth of 50 millimeter. The lower end is case hardened with a chamfer of 2 millimeters. A lifting handle is provided to lift the hammer. We have a locking pin here which is used to lock the hammer in position when not in use, and during the conduct of the test this can be removed. A release pin and an adjustable stop screw which can be used to adjust the height of free fall of hammer. A ratchet counter is provided to count the number of blows. The free fall of hammer is between 380 plus minus 5 millimeters. The hole of the machine should be fixed with a solid base, preferably of concrete, such that it is stable in position. The other apparatus mainly consists of a cylindrical measure of internal diameter 75 millimeter and depth 50 millimeters. A tamping rod of length 230 millimeters and diameter 10 millimeters. A cylindrical metal cup which is case hardened on the internal sides, having internal diameter 102 millimeter and depth of 50 mm. The sample is placed in the cylindrical cup while testing. In addition, we need IS sieves of size 12.5 millimeters and 10 millimeters. These are required to select appropriate sample size. IS sieve of size 2.36 millimeter is required to sieve the sample after the test has been conducted. We also need a weighing machine of capacity 500 grams and accuracy 0.1 gram. An electronic balance conforming to this specification is the most suitable. The sample that is used during the test should be oven dried at a temperature 100 to 110 degrees centigrade for 4 hours and allowed to cool at room temperature before using in the test. Now, we shall see the actual conduct of the test. Sieve the oven dried material through 12.5 mm and 10 mm sieves. The material retained on 10 mm sieve and passing through 12.5 mm sieve comprises the test sample. Take the cylindrical measure and note down its weight. Now fill it up to 1/3 depth with the aggregate sample. Compact by giving 25 gentle blows. In the similar manner, fill the other two layers. strike off the excess material determine the weight of the cylinder filled with aggregate to the nearest 1 gram. The aggregate contained in the cylindrical measure comprises the test sample. Fix the cup firmly in position. Transfer the aggregate in the cup in a single layer and compact by giving 25 gentle blows. Remove the lock and raise the hammer. Lift it to give blow. In the similar fashion, give 15 blows. The interval between successive blows should not be less than 1 second. Now lock the hammer . Remove the crushed material from the cup . Pass the crushed material through 2.36 mm sieve. Weigh the fraction passing through the sieve to an accuracy of 0.1 gram. In this case, the weight is 61.1 gram. As a check, also weigh the fraction retained on sieve. The aggregate impact value is determined as weight of fraction passing 2.36 mm sieve as a percentage of total material taken. Repeat the test and the mean of two samples is reported as the aggregate impact value. Based on impact value, the aggregates are classified as exceptionally strong, strong, satisfactory or weak. Indian Road Congress has specified limits for different types of road construction. For the aggregate sample tested here, the impact value is found to be 18.6%. Therefore, this aggregate is classified as strong. It meets the criteria for use in road construction as well as for concreting operations. In this program, we have seen as how the impact value of aggregate is determined. Similarly, other properties of aggregate can be evaluated to judge the suitability of their use in construction. Thank you and goodbye.